we shall be finding derivatives of a function. Okay, so we will be looking subsequently at the theories of derivative of a function. That is, we will be explaining the concept of the derivative of a function. So you could check out that video when it is uploaded or when we go live on that video. So in today's video, we shall be looking at how to solve problems on derivatives of the function. So we shall be taking so many problems on derivative of the function. Please like the video, share the video, and do well to subscribe to the channel if you haven't subscribed to the channel, okay? And endeavor to turn on your notification bell. Now let's begin. So I'm going to start with problem number one. And in problem number one, we shall be looking at the problem this, okay? So problem number one says the function f of x is given. The function f of x is given by f of x equals 2x raised to power 3. So we are asked to write, the question says, write down and simplify the expression f of x plus h minus f of x all over h, in which case h is not equal to 0. So let's start with this problem. Now, if you have a problem like this, guys, how do you solve this problem? So again, let me read. The function f of x is given by f of x equals 2x cubed. Write down and simplify the expression this, provided h is not equal to 0. Now, let's start with solving this problem. So all you have to do, should you be given a problem like this, is to start with the first thing. Write down the expression and then simplify it. So I'm going to do this. I'm going to start with obtaining an expression for f of x plus h. Now, if you look at this expression they've given to us, it carries f of x plus h. So I'm going to write down the expression for f of x plus h. How am I going to do that? Take note, you have been given an expression for f of x already, that f of x is 2 times anything x is all cubed. So f of x plus h, if it follows the pattern of this function, will be 2 times what we have x to be. In this case, x is x plus h all cubed. So what have I done for f of x plus h? Using the pattern of this function, I have simply replaced x in this function with x plus h. So it now becomes f of x plus h equals 2 in bracket x plus h all cubed. Now, I'm going to simplify this expression immediately by using the expansion. So when you expand x plus h all cubed, you would end up having x cubed plus 3x squared h plus 3x h squared plus h all cubed. And if you simplify further, this will give you 2 times x cubed will give you 2x cubed. 2 times 3x squared h will give you 6x squared h. And 2 times 3x h squared will give you 6x h squared. And finally, you would end up having 2 times h cubed to give you 2h cubed. Okay? So, what have I done? I've been able to get an expression for f of x plus h simplified. Now, I'm going to write here the expression for f of x. So we were told f of x is equal to 2x cubed. Okay? Now, looking at the board, we have obtained a simplified expression for f of x plus h. We have obtained a we have written down the expression for f of x, which was 2x cubed. Again, just in case you are joining us, take note, what we have just done is to start with obtaining an expression for f of x plus h using the pattern of the function given to us, and we've simplified that expression to get this. Now, the next thing is to recall that f of x, we were told, is 2x cubed. Now, Having gotten these two results put in place, let us now go over to what is demanded. So what are we demanded? What is demanded of us is f of x plus h minus f of x all over h. This will now become putting the result for f of x plus h, which is this 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed, okay, minus putting the result for f of x, which is 2x cubed, all divided by h. Okay? Now, obviously, a cancellation will take place here because 2x cubed minus 2x cubed would go off. And that is because both of them are like terms, they cancel themselves. And you end up having 6x squared h plus 6xh squared plus 2h cubed all over h left. Okay? Now, once you get to this point, what would you do? This is the same as simplifying further to get 6x squared h over h. Okay? Now, plus, since they all have an LCM h, then this will be 6xh squared over h plus 2h cubed all over h. Okay? And h cancels h cancels h squared to leave you with 1h, h cancels h cubed to leave you with h squared. So your final result, if you come over here, the final result for f of x plus h minus f of x all over h becomes 6x squared plus 6xh plus 2h squared. And that becomes the final result for what we were demanded to do. Again, the question had asked us to write down and simplify the expression for this. So this, when simplified, gives this expression, and this is the expression we were asked to find. Now, this concludes problem 1, okay? Now, let's move over to another problem. Let's move over to another problem. So, the second problem I'm going to be looking at in today's class is this. So, we are also asked to do the following. We are told there's a function g of x, and it is defined. This function is defined by g of x equals x in bracket x plus 1. And we are asked to find the limiting value. Find the limiting value of g of x as x approaches 2. Now, you may go back to my part 1 video or my video on limit. The link, I'll put the link after this class in the description below. So you could go back to that video on limits to understand what we are going to be doing here. Now, the question number 2 says there is a function g of x and it is defined by this expression, that is g of x is given as x in bracket x plus 2, and we are asked to find the limiting value of this function g of x as x approaches 2. So what do you do? As a solution to the problem, all you have to do is this. Write your function g of x and take the limiting value. Take note, if you go through the video I made on limits, you realize that we represent limits as LIM. So LIM as x tends to 2, what we are as x approaches 2 is written in this manner. You write LIM x arrow 2 and in bracket you put g of x, the function whose limit we want. And since this is the case for the left hand side, you would have to come over here. Taking the limit of g of x as x approaches 2 is the same thing as taking the limit of what g of x is. And g of x, mind you, is x in bracket x plus 1. Okay? Now, in that class on limits of a function, I gave certain rules on limits, where we took the limit of a sum as one property is the sum of the limits. The limit of a quotient, provided the denominator is not equal to 0, is the quotient of the limit. The limit of a product is the product of the limit. So we are going to apply that rule here. Now there are two ways you could go about this. You could expand this function. Of course, it will end up giving you a polynomial function, or you simply would use the property of limits. So I could use either of them. Let's say we use the property of limits. The limit of a product is the product of the limit. So limit of, take note, in this function x in bracket x plus 1, there are two component functions. One function is x on its own, and the other function is x plus 1. So assume that there is a function u given as x, and there is another function v given as x plus 1. So you will come to realize that if we call this function here, if we call u, if we say u is a function equal to x, and v is another function such that v is equal to x plus 1, then this becomes a product of u and v. So the limit of the product of these two functions will be the functions, the product of their limits. So this will be limit of x multiplying the limit as x tends to 2 of x plus 1. So if you don't understand what is going on, please check out my videos on limit of a function, okay? Now, how in that video again, please take note. I told you that to find the limit of a polynomial function requires direct substitution. So all you have to do is to put the value to which x is approaching straight into the function and simplify. It will give you the result. So if I'm taking the limit of x as x tends to 2, that limit will simply be obtained by putting 2 in place of x, and that limit will be 2 multiplied by, if I'm to obtain the limit of x plus 1 as x tends to 2, since x plus 1 is a polynomial function, all I have to do is to put 2 in place of x and simplify. So if I put 2 in place of x, it becomes 2 plus 1, the result, and that will give me 3. So the limit as x tends to 2 of this function will be 6. Okay? So it is as simple as that to obtain the result for problem number 2. Remember, this class, this live class, is completely, absolutely on finding and solving problems on the derivatives of a function. Okay, so we are going to be looking at, welcome Samson, I've seen you. So we are going to be looking at problem number 3. Let's quickly go to problem number 3. So we have looked at problem number 1, we have looked at problem number 2, and we are now about entering problem number 3. So we are going to be taking so many problems as possible in today's live class. So if you are watching this video from any part of the world and you have not subscribed to the channel, please do us a great deal of good by clicking the subscription button. Subscribe to the channel, turn on your notification button after subscribing so that you will get notified whenever we go live or whenever we drop a new video. So this particular channel is all about mathematics, statistics, research. Okay? So please let us now look at problem number 3. So in problem number 3 we have the problem find the limiting value of g of x equals x minus 2 in bracket times x plus 2 as x approaches 3. Okay, so find the limiting value of this. Again, I will solve this problem using the product rule of limits. Remember, the limit of a function, the limit of a product is the product of the limits. So when we are giving two functions, a product of more functions, rather more than one function, probably 2. All you have to do to obtain the limit of that function is to obtain the limit of the individual function and multiply whatsoever your result is. So if I'm taking the limit as x tends or approaches 3 of g of x, doing this will be the same thing as taking the limit as x approaches 3 of what g of x is. And mind you, g of x, we are told, is a product of two functions. One of them is x minus 2 and the other one is x plus 2. Now, please take note. You could simplify by expanding this and getting the final result and then taking the limit, you will still get the same result. So I'm going to apply the property of limit that says limit of a product is the product of the limit, meaning I'm going to do this limit of x minus 2 as x tends to 3 times limit as x tends to 3 of x plus 2. So that's the first step I'm going to take. Now, because each of them are polynomial functions, all I'm going to do would be to simply replace, in place of x, I'm going to be putting 3. So this will give me 3 minus 2 times, in place of x, I'm going to be putting 3 again. This will give me 3 plus 2. So the result simplifies to 3 minus 2 times 3 plus 2, and that will give you 3 minus 2 is 1, 3 plus 2 is 5, and that will give me the limit of that function as 5. Take note, polynomial functions, the limit of polynomial functions are obtained by direct substitution. So all you have to do is substitute for the value of x as x, the value to which x is approaching, and then simplify. Now, let's go to problem number 4. So for problem number 4, we are asked to, we are given this. We are told if f of x is equal to 3x squared, we are asked to find this. The limit as h tends to 0 of this, f of x plus h minus f of x all over h close bracket. Now please take note. In my video on the derivative of a function, you are going to realize that this defines what we call the derivative of a function, especially using first principle. Whether with first principle or not, this defines the derivative of a function, okay? So the derivative of a function is defined to be the limiting value of what is called the gradient function for that function. So if I'm to find the derivative of a function like this, using first principle or using the derivative technique, I am going to obtain for this function what is called its gradient function, and thereafter obtain the limiting value as h, the change in the independent variable, tends to 0, becomes infinitesimally small. So what I'm going to do here will be to solve this problem. I'm going to write solution. Now, the first thing you are going to do if given a problem like this is to find the components. So you know f of x to be 3x squared. So start with writing f of x out. F of x, you are told, is 3x squared. So if f of x or f of anything is 3 times that thing all squared, what will f of x plus h be? So if f of x is 3 times x all squared, then f of x plus h, when your x is now in x plus h, becomes 3 times what your x now is, which is in this case x plus h all squared. Now, I would tell you, I would suggest you simplify immediately when you get to this point. So what I'm going to do is to expand this. This will give me x squared plus 2xh plus h squared. When I expand what is inside the bracket all squared. Okay? Now if I expand further to use that is using 3, what is outside the bracket, to multiply what is inside the bracket, this will give me 3x squared. When I use x3 to multiply x squared, 3 multiplying 2xh will give me 6xh, and when 3 multiplies h squared, it will give me 3h squared. So this is my final result for, or final expression for f of x plus h when it is expanded and simplified. Okay? Now, but that doesn't solve the problem. We are asked to find the limiting value as h tends to 0 of this. So what I'm going to do next is to find f of x plus h minus f of x. Now take note, this expression f of x plus h minus f of x is the numerator of the expression inside the bracket. So I'm going to simply do this. F of x plus h, we are told, we've now obtained to be 3x squared plus 6xh plus 3h squared. Okay? So, now, if I subtract from this expression for f of x plus h, f of x, the expression for f of x, that's what I'm going to have. Now you will notice that 3x squared minus 3x squared goes off, and it now gives me this expression f of x minus f of x plus h minus f of x to be 6xh plus 3h squared. Okay? Now, if I move further with a step to dividing the final expression I've obtained above by h, it would imply dividing 6xh plus 3h squared by h. Now, doing this simply means dividing each term in the numerator by h. So if I divide each term in the numerator by h, I'm going to have h cancelling h, and my result will be 6x, and when h cancels h squared, I'll be left with 3h. Okay? So what have I done? I have been able to obtain an expression. I've been able to obtain an expression for f of x plus h minus f of x, okay, all over h. So what is that expression we've obtained? We've obtained it to be this. Now, but this is not what the problem is all about. We are asked to go further to obtaining this, the limiting value as h tends to 0 of f of x plus h minus f of x all over h. And what have we gotten? We've gotten this expression within the bracket to be 6x plus h. So I'm going to, taking the limit of this is the same as taking the limit of this. So I'm going to take the limit of this expression we've obtained, 6x plus 3h. Now, when x approaches 0, what will become of 6x plus h? If h approaches 0, the limiting value of 6x plus 3h becomes 6x plus 3 times what h is approaching, which is in this case 0. So 3 times 0 will give you 0, and 0 added to 6x will give you 6x. That tells you that the limiting value of this expression obtained from this will be 6x. Okay? Now, you will come to realize again when you watch my video on the derivative of a function that what we have just done is obtaining the derivative of this function. So the derivative of f of x, if f of x is equal to 3x squared, is 6x. That's what we've just done. Now, that being said, let's move over. So welcome to all of you joining the class. Welcome. I can see a lot of you online. So welcome to the class. Let's move over to problem number 5. Let's move over quickly to problem number 5. So let's go to problem number 5. So for problem number 5, what are we demanded to do? We are asked to do the following. So the problem says problem number 5 says find the gradient function. You must have heard me mention at the beginning of this class the gradient function. So find the gradient function of y equals x squared plus 3x plus 1. Okay? Now, question number 5 says find the gradient function. Take note, the gradient function, guys, is not the same as the derivative of the function. And so many students are unaware of what the gradient function is. Again, I must tell you, just in case you've not watched my video on derivative of a function or you'll be watching it later on, please take note of one thing, that the gradient function is simply obtained by taking the ratio of a change in the dependent variable to that of the independent variable. Okay? Now, to solve this problem, all we have to do is the following. Okay? Now, there are so many ways to go about it, but I'm going to use this. Now, the first step I'm going to take in solving this problem, I could use another step and another procedure I'm going to show you. Now, the first step I'll do is this. I'm going to increase my dependent variable by a small change in y. And that would mean implementing x, changing x all squared. So a change in the dependent variable must have come by a small change, a corresponding small change in the independent variable. So this will give me x plus change in x plus 1. Okay? Now, if you don't want to do this, I could show you another way of going about the problem. So, what are we trying to do, guys? We are trying to find the gradient function. Now, please, before you get confused, what we want to obtain, what the gradient function is. The gradient function is a ratio of a change in the dependent variable to a change in the independent variable. This ratio is called the gradient function in this case, under derivatives of the function. Okay? Please take note, it should not be confused with the gradient. Both of them are almost the same. Gradients would always produce constants, but the gradient function could produce a constant or may produce a function. So please take note, they are similar but not exactly the same. Now, how do we obtain the gradient function? The first thing we are going to do is to look at the function y equals x squared plus 3x plus 1 and increase the independent variables, the arguments, by an infinitesimal change. So I'm going to start with increasing x by changing x. So x squared becomes x plus change in x all squared. And I'm going to increase x here, that is multiplying 3, by changing x, and it becomes 3 in bracket x plus change in x. This is a constant, and no matter how the change comes up, it does not affect the constant, so the constant remains 1. Now take note of one thing. If y equals x squared plus 3x plus 1, it means that y is a dependent variable depending on x. And anything that affects x, if there is an infinitesimal change, that is a very small change in x, the independent variable, it will consequently affect or influence or impact a small change in the dependent variable. So that is where to begin the problem from. So the next step would be, as a step 2, what I'm going to do will be to make change in y, the dependent variable, the subject of formula. So I'll end up having this. Now, take note, I've not expanded yet, just my choice. You could expand. There won't be any problem doing that. Okay? Now, let's expand all at once. I'm going to make y, change the y the subject of formula, and then simplify. So when I do that, I'm going to have x squared plus 2x change in x plus change in x all squared plus 3x plus 3 in bracket change in x plus 1 minus y. And take note, what were we told y is? Y is x squared plus 3x plus 1. So I'm going to put here in bracket x squared plus 3x plus 1. Now, in order to avoid any form of confusion, let me clean up this we had done previously. That is question number 4. So let me clean this off quickly. Now, please feel free to ask a question as you join the class. If you haven't subscribed to the channel, please subscribe to the channel. For this week, throughout this week, we shall be solving problems on differentiation, application of differentiation, integration, application of integration, and problems in two-dimensional rectangular Cartesian. We shall be looking at those problems. So please just join the live class. You'll be glad you did. So this is changing y equals x squared plus 2x in bracket changing x plus changing x all squared plus 3x plus 3 in bracket changing x plus 1 minus times x squared will give you minus x squared, minus times 3x will give you minus 3x, and minus times 1 plus 1 will give you minus 1. Now at this point in time, there will be some cancellation. Now take note that this x squared minus x squared gives 0. And another thing that will cancel is 3x minus 3x will give you 0. And then 1 minus 1 will give you 0. So we will be left with change in y equals 2x in bracket change in x plus change in x all squared plus plus 3 change in x. So that's what we are going to have when every other thing cancels. Okay? Now, let's bring, so what have we obtained? We've obtained change in y to be, simply put, all these squared plus change in x squared, okay? Yes, plus 3 change in x, if I'm correct. Okay, so let's examine just to be sure that we've not made any mistake. So this was my expansion for this was my expansion for this, and this was my expansion for that. Okay, now this cancels that, 3x cancels that, 1 cancels, and so we are left with 1, 2, 3. Okay, so we are actually correct. Now, remember, what are we asked to find? We are asked to find the gradient function. And guys, what is the gradient function? Please take note, just in case you never knew. The gradient function is a ratio of an expression for change in y to change in x. So what have we obtained? We've obtained an expression for change in y. So to obtain the gradient function, we would now divide the expression we've gotten for change in y by change in x. And that would imply dividing what we had above by change in x. And dividing these terms, the sum of these terms by change in x simply means dividing each of them by change in x. So I'm going to be dividing them, each of them here, by change in x. Okay? So if you divide each of them, let me quickly clean this off. So if you divide each of them by change in x, you are going to have this. And the final result, change in x will cancel one of the change in x in change in x squared, and I'll be having 2x, plus change in x will cancel one of these, and you'll be having change in x, plus change in x will cancel this, and you'll be having 3. So your problem reduces to 2x plus 3 plus change in x. This is the gradient function, and that's where they want you to stop the problem. Okay? So when the problem demands that you find the gradient function for this expression, it means obtain that result. Okay? And that solves problem. Yes. Okay.
2x change in x squared.
Okay. So yes. That's what 2x change in x squared. We're
We're not supposed to have squared.
Okay. We are not supposed to have a square, yeah?
Yeah.
We are not supposed to have a square here.
Those two.
Yes. So thanks. Okay. So I believe we are okay. Yes, we are. So this cancels, and that's what we are left with. So please, guys, go over it again. It is that simple. Now, let's quickly clean up and go over to problem 6. Let's go over to problem 6. Okay, so for problem 6, we shall be looking at another problem I have here that says, for problem 6, it says find the gradient of the tangent to the curve, the gradient of the tangent to the curve y equals 2x squared plus 5x minus 3 at the point where x equals 1. Okay? So let's assume that this is actually a curve and this is a tangent to the curve. Okay? So we are asked, okay, for better understanding, let me even do this rather. Let me do this. Let's assume we have a curve and this. Remember, a tangent is a straight line that touches a curve or a circle at one and only one point. So we are asked to find the gradient of the tangent, that is this line. This is what we are asked to look for. Okay? The gradient of the tangent to this curve. So let's assume that this curve describes 2x squared, y equals 2x squared plus 5x plus 3. So remember, for a straight line, the gradient can be found with any 2 points. But for a curve, the gradient is found at using the tangent. The gradient is found using the tangent to the curve at a certain point. So if you want to find the gradient on a curve, it changes from point to point on that curve. As such, if you are to find the gradient of a curve at a specific point, say x equals 1, then you would have to obtain the gradient using the tangent to the curve at that point. So what we are going to do quickly is to okay, so we are going to do the following. So let me quickly clean this off. So what will be our first step in solving this problem? Our first step in solving this problem will be to obtain the derivative of this function and then substitute for x equals 1. So if y, as a solution to the problem, if y equals 2x squared plus 5x plus 3, then dy dx, the derivative of this function will be 2 times 2, which is 4, 2 minus 1, which is of course 1. So this will give us 4x. We will be using term-wise differentiation. So differentiating this term 5x will give you 5, and differentiating the constant gives you 0. So this is the gradient, this is the derivative of that function. So the next thing we have to do to obtain the gradient of the tangent to the curve, this curve at the point 1, will be to do this. You simply write a straight line and put at the bottom x equals 1. That would imply substituting for 1 wherever you find x in the result we've obtained, and that will be 4 times 1 plus 5. And what is 4 times 1? It is 4. 4 plus 5 will give you 9. So it tells you that the gradient of this curve at the point x equals 1 is 9. And that solves that problem. Okay? So it is as simple as that. Now let me quickly go through. So Charlie, you are not late. Welcome. Favor, welcome. Okay, so welcome to the class. Welcome and welcome. Now let's go to problem 7. Now please, as you enter the class, just in case you don't understand anything, you could go back to the beginning by sliding down to the beginning, or you could ask questions on whatever you don't understand. Feel free to ask questions, please. So let's look at problem 7. So I'm going to put problem 7 over here. Now, what is problem 7 saying? Problem 7 says find from the first principles, the derivative of y equals 3 over x, okay, with respect to x. Now, I don't know if you're familiar with first principle, but I'm going to show you how to use it using this particular problem, okay? So we are asked to differentiate y equals 3 over x using the first principle of differentiation. Now, just in case you don't know how to differentiate using first principle of differentiation, let's use this problem to show you how. I can tell you it is very, very simple. So what do you have to do, guys? The first thing you have to do is this. So I'm going to be breaking down my solution into steps, okay? I'm going to be breaking my solution into steps. So let's write here solution step 1. When given a problem like this, according to first principle, the first thing you do is to increase the argument, that is the independent variable, by a small change in x. Now, the function given to us is 3 over x. So I'm going to increase the independent variable in that function, that is x, by a very small change. So the small change will be represented with delta x. So delta x represents an infinitesimal change in the argument or the independent variable x. And take note, if y depends on x, it means that y is the dependent variable and x is the independent variable. And any small change that affects x will consequently affect y. And that will mean, because we have increased x by a small change in x, then it will impact a small change in y. Okay? So that is the first step you take in doing this. So what do? Increase increase x by a small change in x and increase y by a small change in y. Now, the next step you will take is to make this the subject of formula. That is, make your change in the dependent variable the subject of formula and then simplify. So if I do that, this will become 3 over x plus change in x minus y. Okay? When y, of course, comes over to this side of the equal to. So what is your y? Remember, we were given y to be x 3 over x. So I'm going to put what y is here, 3 over x. Okay? Then I'm going to simplify, still in this step 2. When you simplify, the LCM of x plus change in x and x is the product of the two of them. So I'm going to put up my LCM here. The LCM of x and x plus change in x is the product of the two of them. Now, when this goes into this LCM, it cancels itself, leaving us with x. So x times 3 gives us 3x minus, when x goes into the LCM, it cancels itself and leaves us with x plus change in x. And x plus change in x goes to multiply 3 to give us 3 in bracket x plus change in x. Okay? Now, if you simplify further, you will end up having 3x minus 3 times this x here gives you minus 3x, and minus 3 times change in x gives you minus 3 change in x, all over x in bracket x plus change in x. Okay? So let's continue the problem over here. Let's continue the problem over here. So I'm going to bring the problem over here and then say the following. So what am I going to do here? I'm going to continue this problem by saying change in y therefore will be 3x minus 3x goes, so I'll be left with minus 3 change in x in the numerator, okay? And in the denominator, I'll be left with x squared plus x change in x. Now, this completes the step 2 in the first principle of differentiation. Now comes step 3. So what are we going to be doing in step 3? Once you obtain a final expression, a simplified expression for change in y, the next thing you are going to do is to obtain what we call your gradient function. Now, for those of you just entering, please, the gradient function in differentiation simply talks about the ratio of the simplified form of change in y to change in x. So all you have to do is to say minus 3 change in x all over x squared plus x change in x divided by change in x. Okay? And that would mean minus 3 change in x. I'm going to do this so that it is easily understood. Okay? Now, minus 3 x squared plus x change in x. When this division is changed to multiplication, we take the reciprocal. So this becomes 1 over change in x. And it simplifies to minus 3 change in x. Of course, you will clearly see that change in x can cancel this, and we are left with minus 3 all over x squared plus x change in x. Now, this concludes our step 3. The fourth and final step would now be, once you are done doing this, the fourth and final step would require you to take the limiting value of the gradient function. Take note, guys, the limiting value of your gradient function gives you your derivative. So what is the y? The x. The y, the x, which is the derivative of y, the function with respect to x, is obtained by taking the limiting value as change in x tends to 0 of the gradient function. So, in this case, all we have to do, since our gradient function is equal to this, is to put 0 wherever we find change in x. And if you put 0 into wherever we find change in x, this will become 0 times x, giving you 0, and 0 plus x squared will give you x squared. So your problem reduces to minus 3 over x squared. And that solves that problem, okay? So it means that when you differentiate the function y equals 3 over x, your result will be minus 3 over x squared. And that solves problem number 7. Okay, without much waste of time, let's move over to problem number 8. And I would advise after this class, you go over the video and watch from start to finish to understand better what we have done. And please do well to ask questions just in case you do not understand what is going on, just in case you joined late or just in case you are not familiar. And I would ask that you check our videos on differentiation after this particular live class. So let's go to problem 8. Let's go to problem 8. So problem 8 says find from first principle the derivative of 2x squared minus x with respect to x. So as a solution to this problem, what I'm going to do will simply to say, I'm going to say let y be equal to 2x squared minus x. Okay? So I've just called y a function that depends on x through this expression 2x squared minus x. Now, using first principle again, the first step I'm going to take will be to increase change in y and change in x by infinitesimal changes. So change in y increases by change in y as a result of x increasing by change in x. Okay? So this is what we have as our first step. Now, I'm going to make change in y the subject of formula, and that would mean having this. Now, after doing this, the next thing I'm going to do will be to expand and simplify. So this will be x plus change in x all squared will be x squared plus 2 in bracket x change in x plus change in x all squared minus x minus change in x minus what y is, and y, take note, is 2x squared minus y. So minus y will be minus 2x squared plus x. Okay? So I'm simplifying in straightforward manner. Now, if you expand, this will give you 2 times x squared is 2x squared. 2 times 2 gives you 4. So you end up having 4x change in x. And 2 times this gives you 2 change in x all squared. So minus x minus change in x minus 2x squared minus plus x. Okay? So for clarity's sake, let me quickly clean off this. I'm going to clean this off so you could see clearly what we are concentrating on. So that's what you're going to have. Now we will look at what simplifies. 2x squared minus 2x squared gives you 0, so that goes. X minus x plus x gives you 0, so it goes. And we are left with the following. So changing y, which was this, becomes 4x in bracket change in x plus 2 change in x all squared minus change in x. Okay? So it simplifies to this. Okay? Now, once we are done with that step, we will go over to obtaining the gradient function. And the gradient function will be obtained by dividing change in y, what we got, by change in x. So that will be 4x change in x plus 2 in bracket change in x all squared minus change in x all over change in x. And that would mean change in y over change in x. When you divide each term by change in x, that will give you 4x change in x all over change in x plus 2 change in x all squared all over change in x minus change in x all over change in x. Okay? And that would end up giving you change in x cancelling change in x here. Change in x cancelling one of these and change in x cancelling this. Okay? Now, let's go over what we've done so far. So we started the problem with saying this minus this will result in y plus change in y equals 2 in bracket x plus change in x all squared, because we are increasing this, minus x plus change in x. Now, we went further to doing the following. We went further to making change in y the subject of formula, and we got this, where y came over to become minus y, and this when expanded gave us this minus x minus change in x, then minus what y is. Take note, y is 2x squared minus x, so minus y will become minus 2x squared plus x. And we expanded to get this 2x squared plus 4x change in x plus 2 change in x all squared minus x minus this. And simplifying meant that we had to cancel out like 10. 2x squared cancelled out 2x squared by that is 2x squared minus 2x squared. Then we had minus x plus x giving us 0, leaving us with what we had here. Now, we had to move over to getting the gradient function, which was this. Gradient function, take note, is the ratio of change in y to change in x, and that resulted in dividing what we obtained for change in y by change in x. And doing that meant dividing each term of the numerator by change in x. When we did that, we had to simplify by cancelling out. Change in x cancels change in x, change in x cancels one of these, and change in x cancels that, and this is where we are at the moment. Change in y over change in x will be equal to 4x plus 2 change in x minus 1. Okay? Now, the next stage will be to obtain the derivative, which is dy dx. And how do you obtain dy dx? I've told you again, dy dx is the limiting value as change in x tends to 0 of the gradient function. So when you take the limiting value of your gradient function as change in x tends to 0, it gives what we call the derivative. And that means taking the limiting value of this gradient function means taking the limiting value of what we had, which is this. So that would mean putting change in x as 0 wherever you find change in x. And the only place you find change in x is this. So 2 times 0 gives you 0. And you end up having 4x minus 1 as our result. So dy dx is 4x minus 1. Okay? So that is the solution you would get when you use the first principle of differentiation to solve problem 8. Now, let's move over to problem 9. Okay? Let's move over to problem 9. Let's move over to problem 9. So what does problem 9 say? Okay, so what does problem 9 say? Problem 9 says find the derivative with respect, so this is problem 9. Find the derivative with respect to x of the function y equals x plus 1 over x from first principle. Now, in this particular question, I'm going to apply this. I'm going to say y, let y be equal to f of x. So it means that f of x is equal to this. Okay? If you don't want to use this technique I've used earlier on, you could also use this technique. Okay? What I'm about to show you now. Just in case you're not comfortable with using this one we've used previously, you could use the technique I'm about to show you now. So what I'm going to do is, now f of x is equal to x plus 1 over x. I'm going to obtain f of x plus h. I'm going to obtain an expression for f of x plus h. An expression for f of x plus h means wherever you find x, you now end up putting x plus h. So I'm going to put x plus h here, plus 1 over x plus h. Okay? So this is over 1 plus 1 over x of h. X plus h rather. So the LCM of this is x plus h, obviously. The LCM of 1 and x plus h is x plus h. So 1 in x plus h will give you x plus h. So you end up having x plus h times this, giving you x plus h all squared. Plus x plus h into x plus h is 1. 1 times 1 gives you 1. So this will give you x squared plus 2xh plus h squared plus 1 all over x plus h. So what have we just done? We have just obtained an expression for f of x plus h using the expression given to us for f of x. Okay? Now, let's come over here. Let's come over here to continue the problem. So I'm going to do this. The next thing I'm going to do, now that I have an expression for f of x plus h, and I know the expression for f of x, I'm going to do the next thing. I'm going to obtain an expression for f of x plus h minus f of x. That would mean writing this out, what I had as my f of x plus h minus what I was given as my f of x. Now please take note, we could just write this simply. The LCM of 1 and x is x, and 1 into x is x. X times x will give you x squared, plus x into x is 1, 1 times 1 is 1. So I'm going to write here x squared plus 1 over x. Okay? So now the LCM of x plus h and x will be the product of the two. Okay? Now this into the LCM gives x. X times this numerator will give you x in bracket x squared plus 2xh plus h squared plus 1 minus x into this denominator gives you x plus h. So x plus h times x squared plus 1 is what you have here. Okay? Now, you could simplify further by saying expanding. This gives x cubed plus 2x squared h plus x times h squared is x h squared plus x times 1 is x. Then let me bring this further, minus now expanding this, you have x times x squared is x cubed, x times 1 is x, h times x squared is hx squared or x squared h, whichever one. Okay, then h times 1 is h, all over x squared plus xh when you expand the denominator. Okay, so if you expand further, you end up having x cubed plus 2x squared h plus xh squared plus x, minus opens this bracket to give you minus x cubed. So let me bring this one down. Minus opens this bracket to give you minus x. Minus times x squared h will give you minus x squared h. Minus times this will give you minus h all over x squared xh. Now let's go over the problem again from the beginning quickly. So we were given f of x to be x plus 1 over x. So I started with simplifying this to get the LCM, and simplifying gave us x squared plus 1 over x. Then comes getting f of x plus h. An expression for f of x plus h comes directly from the expression for f of x. So if f of x is defined as x squared plus anything you have here, all squared plus 1 over x, then f of x plus h would become anything you have here, that is x plus h all squared plus 1 over x plus h. Obviously, expanding x plus h all squared gave x squared plus 2xh plus h squared then plus 1 all over x plus h. And that was our final expression for that. So, subtracting f of x, which is x squared plus 1 over x, from f of x plus h, which is this, gave us this line of our problem. And taking the LCM meant x plus h, and the LCM of x plus h and x gave the product of the two. This into the LCM gave us x. So the expansion of this meant using x to multiply this bracket. X times x squared gave us x cubed. X times 1 gave us x, which is this. H times x squared gave us x squared h, and h times 1 gave us this. Now opening up that bracket meant using minus to multiply everything here, which is minus x cubed minus x squared h and minus h. So at this point in time, we are going to simplify. So simplifying means this x cubed minus x cubed goes, okay, and x minus x. So we are left with 2x squared h plus x squared minus x squared h. Now 2x squared h minus x squared h will give you x squared h. And I will bring this x h squared minus h all over x squared plus xh. Now, what have we obtained? We have just obtained a final expression. We have just obtained a final expression for the numerator there. So we've obtained f of x plus h minus f of x to be x squared h plus xh squared minus h all over x squared plus xh. Okay? Now the next thing we are going to do in our next step, we are going to divide this by h. Dividing this by h means having x squared h plus xh squared minus h all over x squared plus xh divided by h. And that means x squared h plus xh squared minus h all over x squared plus xh times 1 over h. And this will give us x squared h plus xh squared minus h all over x squared h plus xh squared. Now, I could have cancelled at the very beginning by factorizing and cancelling, so I can still do that at this stage. So h comes out in the numerator to give you x squared plus x minus 1 all over h comes out in the denominator to give you x squared in bracket plus xh. Okay? Now this h cancels this h, so we are left with x squared minus x minus 1. Okay, x, this, of course. So this is our final expression for this. So to obtain the y dx, we would have to take the limiting value as h tends to 0 in this case of f of x plus h minus f of h, okay, all over h. And that would mean taking the limiting value as h tends to 0 of this. Please take note, as h tends to 0, whatsoever is h in this expression becomes 0, and we will be left with the y dx equals x squared plus x minus 1 all over x squared plus 2x times 0, or plus x times 0. And that will result in x squared plus x minus 1 all over x squared, because x times 0 is 0, and 0 plus x squared will give you x squared. So it means that when you differentiate this function, the result will be this. Now please take note, some of you might ask, why is differentiation using first principle so long? Must I always use first principle of differentiation? The answer is a big no. Okay, so you don't, except the question specifies that you use first principle of differentiation, please don't use it. Okay, there are simpler ways to differentiate the function. If we are differentiated in a simpler manner without using the first principle of differentiation, we would have obtained our result to that problem a long time ago. Okay, so we are only solving using first principle of differentiation because the question demanded that we use first principle of differentiation. So please take note, using first principle of differentiation is not compulsory. There are simpler ways of finding the derivative of a function other than using first principle of differentiation. So let's go to the final problem I will be solving tonight. Please take note, today begins our problem solving series on differentiation. And how many problems are we taking in today's class? We are taking 10 problems. So that was the 9th problem I solved, and this will be the last problem. This will be the 10th problem in today's class, will be the last problem. So in tomorrow's class, we shall continue from problem 11. So this problem says find the derivative with respect to x of y equals 3x squared plus 2 from first principle. Now, as we move along, we will stop using first principle. You will come to realize that there are other problems here I have that are not first principle, okay? So the first set of problems in this series helps you understand better how to use first principle of differentiation. So don't get tired of it. eventually we'll move out from problems that require us to use first principle into problems that require us not to use first principle. So let's see. So from problem 12, we won't be using first principle of differentiation. Okay? So let's see. Now, using first principle of differentiation, we have 3x squared plus 2. I'm going to change again. I could use this, the same method we've used earlier on. Increase y by changing y, meaning that that must have come from x plus changing x all squared plus 2. Okay? Now, if I expand this, this would mean x squared 2x changing x plus changing x all squared plus 2. And that will mean y plus changing y. Now, making changing y the subject of formula means having, let me quickly expand this. Okay, let me leave it this way. X squared plus 2x changing x plus changing x all squared in bracket plus 2 minus y. Okay, so bring the y over. What do we have our y? What were we told our y is? Our y, remember, we were told our y is 3x squared plus 2. So I'm going to put 3x squared plus 2 here. Now let's expand us and simplify. So you have 3x squared. 3 times x squared is 3x squared plus 3 times 2x will give you 6x in bracket changing x plus 3 times changing x squared will give you 3 changing x all squared plus 2. Okay? Minus 3 times minus times 3x squared will give you minus 3x squared. Minus times 2 will give you minus 2. And that will give us changing y equals 3x squared. Now 3x squared minus 3x squared gives you 0. 2 minus 2 gives you 0. So you'll be left with 6x changing x plus 3 changing x all squared. And that's what changing y simplifies to. Now, once you are done getting an expression for, once you get up to an expression for change in y, please take note, the next thing you have to do is to obtain the gradient function. And guys, I keep repeating, the gradient function is a ratio of your change in y expression to your change in x value. So that will give you 6x change in x plus 3 in bracket change in x all squared all over change in x. And that simplifies to 6x change in x all over change in x. Using this denominator to divide each term in the numerator, that will be this. Okay? So, that will now give you, when this cancels, you end up having 6x. When this cancels, you end up having 3 change in x. And that will give you change in y all over change in x. Now, having obtained your gradient function, the next and final thing you have to do is to obtain the y, the x. Guys, again, what is the derivative of y with respect to x? It is defined as the limiting value of the gradient function, change in y over change in x, as change in x tends to 0. So that would simply mean putting 0 for change in x wherever you find change in x in the final expression, in your gradient function. So I'm going to put change in x here. That will give me 6x plus 3 times 0. And that results in this. dy dx equals 6x because 3 times 0 is 0 and 6x plus 0 is 6x. So thank you for joining today's class. In tomorrow's class, we will begin with problem 11. And problem 11 is a problem on first principle of differentiation. But after problem 11, we have so many other problems down to problems up to 30. I have 30 problems here to solve on differentiation. Okay, the first part of differentiation. And all of them are no more first principle of differentiation problems. So thank you for staying tuned to today's live class in which we solve several problems on differentiation. In tomorrow's class, we shall continue with problem solving on differentiation, that is finding or obtaining derivatives of a function. Please, if you haven't subscribed to the channel, do well to smash a like on the video and subscribe to the channel by clicking the subscription button and able to tell your friends about the channel, tell your friends about the class, and share the video. Thank you very much. Good night.